Today's lecture of physics, we're gonna see some supplementary quantities. So in the last video, as I told you about, in 1917 SI unit were introduced, but in 1983 some changes occurs in those SI unit. So in 1971 it was introduced in England, and MKS system was converted into SI. This is the key point. So now I'm gonna write a few names, I'm gonna say few names: Newton second, Watt, Joule, Hertz, Pascal, Tesla, Henry, Crews, Coulomb, Cross, Sohn, Rutherford. These were the name of scientists, and they are honored. That is why the unit of them are by their name. So that is why these were few names, and they are honored by their law. If I could tell you that now Einstein has worked in many of the fields of physics, but why any of unit does not exist named as Einstein? Because Einstein did not present the law. The one who present the law is only being honored by. So Einstein only present theories. Now we're gonna see a quick review. If one quantity is scalar and other is vector, so if the question is asking for product, so the answer will be always vector. This is short form. Now we're gonna see two extra supplementary SI units, and that is radian and steradian. So radian is the unit of plane surface. You can refer this plane surface for you can say glass or a 2D shape, two-dimensional shape, for example a circle. So it would be referred as radian is known as radian is the angle. It's an angle between two radii. Now you can see this one is one radii, another is two radii, and that radii is equal to that radii cut off, and into n circumference that is equal to the length of this radius. These radii is plural and singular is radius. So this angle is known as radian. Let me repeat, it is a plane angle between two radii. This is one radii and this is another radii, which cut off an arc on a circumference. This is called circumferences. This line is called circumferences, that is equal to the length of radius. This is equal to the length of radius of the circle. So this is known as radian. Okay, the formula for the radian is R is equal to arc length. Arc length is this part is arc length upon radian. Okay, so 1 radian is equal to 557.3 degrees. Okay, now we talk about steradian. So it is for not for plain substance. That is for gradient. Gradient means a kind of slope, and that is for gradient, and that is for what do we say, angle of solid. So that is of angle of solid, and that is basically in for the 3D shape. So steradian is the unit of 3D shapes, spheres, you can say. Okay, now we quickly gonna talk about the quantities which have same unit. Let me write. Length, we have distance, we have displacement, we have amplitude, another is wavelength, we have and these all are scalar, by the way. Okay, and the unit is meter. Then we have speed and velocity. So the unit of distance upon time, that is meter per second. Then we have momentum, and momentum is the relative unit with impulse. That is, momentum unit is P is equal to m into v, product of mass and velocity, and I is equal to F, force into time. So the unit would be kg meter per second and Newton second. Okay, then we have force, weight and tension. So these unit is Newton, their unit is Newton. Then we have work and we have energy, so their unit is joules. So why we are writing this? The purpose of writing is this, that if they have same unit, so their dimension will be same. If we are taking out the dimension of amplitude, 1 amplitude, 2 amplitude meter, 2 meters, so we don't have to find the length of the dimension length. So that is why I'm writing this scheme. I hope that is clear.